Hello viewers, welcome back to another session of my tutorial. In this video, we're going to solve a differential equation problem, which is a homogeneous first order differential equation. So we have a question here: the y over the x is equal to x minus y over x plus y, as simple like that, and we have to solve for this equation. How do we go about that? So this is the same as the y on the x is equal to, okay, let me write the same thing, x plus y, and this will be equal to the y multiplied by x plus y, which is equal to the x minus y. Now let's test for homogeneity, and the homogeneity we are testing is testing whether the functions here and here, that is function attached to this dy and the dx, are homogeneous. So how do we do that? So we take x plus y and we multiply it by lambda, then also take x minus y, multiply it by lambda, and the case is when I multiply this, or when I put this one inside, I should be able to return it to the normal state. So I'll get lambda x plus lambda y to be equal to lambda x minus lambda y, and I can still bring it back to lambda open bracket x plus y again, lambda open bracket x minus y, meaning it's homogeneous. So at this point, I move straight to my substitution. My y is equal to ux. Once I have this, y prime becomes u plus, that is u plus u prime x. So wherever I see y prime, we'll put this one there, and wherever I see y, we'll put ux. So we're going to get from our differential equation u plus u prime x to be equal to x minus ux all over x plus ux. At this stage, what do? We can see there is x everywhere. We just eliminate them and we get u plus u prime of x is equal to 1 minus u over 1 plus u. Still on it, let's see, we have our u prime here, so let's see what you're going to do. We're going to have u prime of x to be equal to 1 minus u over 1 plus u. Then we send this u there to be minus u, and we simplify this to be equal to 1 minus u. Then we multiply minus u squared all on 1 plus u. So we get u prime of x to be equal to, this will be 1 minus 2u minus u squared all over 1 plus u. So at this point, let me divide my working space. So once I have this, the next thing is to bring this u, du or u prime. I'm going to make it, all these things will come here, and this one will also go there. That is separable. Now you have separated u on one side, and you have x on also one side. So this is the same as du over dx, multiplying x to be equal to 1 minus 2u minus u squared all over 1 plus u. But we ask ourselves, can we simplify this to get this? Maybe simplify this so that it will cancel out. For the first time, let's do our separation. So I'm going to get 1 over the expression 1 minus 2u minus u squared all over 1 plus u to be equal to 1 over x dx. At this point, this place we have the u here, so this one will become 1 plus u over 1 minus 2u minus u squared du is equal to 1 over x du. Then I apply my integral sign on both sides, so 1 plus u over 1 minus 2u minus u squared du is equal to integral of 1 over x du. So at this point, what am I getting? We have integral of this, so applying our integration skills, what are we getting here? I'm going to get, so here I can make a substitution here so that I can have u to be equal to, let's say I can have p to be equal to 1 minus 2u minus u squared. That is solving this alone. So that I'll have the p over the u to be equal to negative 2 minus 2u, and I'll simplify it to be negative 2 out 1 plus u, and that will give me the p over the u. So right now I want to make the u the subject, so the u will simply be equal to negative 1 over 2 open bracket 1 plus u, then that is the p, so the p. So I'm going to change everything here. So tackling only this part, I'm having integral of the expression dp, that is the top one will still maintain 1 plus u over the down is going to be p, then the p over 2 open bracket 1 plus u, then our negative sign 2 will be somewhere here. So still simplifying this, we'll cancel this, and I'll be left with integral of negative 1 out of 2 or p dp, as simple like that. My negative 1 out of 2 will come out, and I'll have negative 1 out of 2 integral of 1 over p dp, and the same as negative 1 out of 2 ln of p, and that is for this side, the u side. So we already made p to be equal to this, so we are going to have negative 1 out of 2 ln of the expression 1 minus 2u minus u squared as our answer for that part of the integration. So let's continue with the other part. So right now I have this part to be equal to negative half ln of the expression 1 minus 2u minus u squared, all to be equal to integral of this will give us ln x, then plus c. So I'll carry this here because it's a logarithmic function. So ln of 1 minus 2u minus u squared to be all to the power negative half is equal to ln of x plus c. So once I have here, what do? I can take exponent on both sides, and when I take exponent on this side, the ln will vanish away. So e to the power ln of 1 minus 2u minus u squared all half negative half is equal to e to the power ln of x plus c. So this is the same as 1 minus 2u minus u squared or negative half is equal to, this also give me, it's a product, will give me x as well as multiplied by e to the power c, and this is the same as 1 over the square root of 1 minus 2u minus u squared is equal to x multiplied by c, because e to the power c will still give us a constant. So now our major aim was to make u the subject so that we find or we complete our substitution, which is y is equal to u multiplied by x. So right now we were to find or make u the subject. So let's see how we can make u the subject from this expression. So how do we go about that? So let's see, applying our normal algebra, we're going to have, let me return it to this form, 1 minus 2u minus u squared negative half, then I'll square both sides again, is equal to xc all squared, and that should give me 1 minus 2u minus u squared to the power negative 1 to be equal to s squared c squared. So this should be also equal to 1 minus 2u minus u squared to be equal to 1 over s squared to the power c squared, like this. So once I have this, I still need to find u. So we'll have to simplify this u expression here. So to simplify this u expression, how do I get? So we have negative 2 here. So factors of So we are going to have the factor of negative 1. So let me remove the negative 1 so that I get negative 1 open bracket u squared plus 2u plus 1 is equal to 1 over s squared c squared. So once I have this, I can say that this is the same as, so in fact this expression is a quadratic equation you have here, and if you make u the subject, then you simply substitute it in this form. And my working space is finished, so I'll continue in the next video. Thank you.